we shall study some very, very elementary properties of general economic equilibrium. I'll rewrite the condition which defines equilibrium. Large vector, etc., can be named general equilibrium for our economic system if it verifies this condition, quality between demand and supply, very good. And every boundary is optimal for the corresponding household. Every production process is optimal for the corresponding firm. And the same condition as before. Let us consider, first of all, let us consider the equilibrium price system. I told you that this is simply an element of the n-dimensional Euclidean space. In other terms, some component of this price system could be a negative number or a null number, not necessarily the components are all positive. In order to exclude a null price for some good or a negative price, we must introduce clearly some further properties about preferences, technology, and so on. First case which we must altogether exclude is the case in which all the components of a price system are null. If prices are expressed in an abstract numeraire, it is possible that every price is equal to zero. But what is the economic meaning of this situation? This means that in equilibrium, every good is a free good. But when this very particular situation arise? Does this particular situation arise? Well, in order to understand this point, let us return to the preference relation. We shall see that a bundle XH, which belongs to the consumption set of any subject, is a satiation point or also a bliss point, point of beatitude, if and only if the set pH of XH is empty. In other terms, it is not possible to find in the consumption set, not only in the budget constraint, but in the entire consumption set, any other bundle which is preferred to XH. Is an unconstrained maximal element, so to speak. Well, it is easy to show that if in equilibrium every price is equal to zero, then every subject is in a satiation point. Why? Because if every price is equal to zero, clearly, for every subject, the budget constraint corresponding to this very particular price system coincides with the consumption set. Every bundle can be purchased because it entails no expenditure at all. But since X star H belongs to dH of P star, if and only if the intersection between pH of X star H and the budget constraint is empty, this is equivalent to write that the intersection between P star H of X star H and the consumption set is empty. But since this set is clearly a subset of XH, we obtain in the end that pH of X star H is empty. So by means of this series of qualities, you obtain that X star H is a satiation point. A global satiation point, not a local satiation point. Is it clear? So every subject cannot find in the entire consumption set any other bundle which is preferred to the bundle he obtained in equilibrium. This is a situation which has no particular interest from an economic point of view. Every need is entirely satisfied. So it is sufficient to suppose that at least one subject is never satiated, in other terms, for that subject, taking any XH in large XH, pH of XH is not empty. It's sufficient to assume these to conclude that the vector P star cannot have all null components. At least one component of P star must be a positive or a negative number, or not a null number. Is it clear? It's sufficient, I repeat, to suppose that there is at least one household H such that for every XH in his consumption set, pH of XH is in this case different from the empty set. It's not a very restrictive assumption. And this eliminates the case of all null prices. So, let us consider now negative prices. There is a way to eliminate from equilibrium negative prices. Yes, there is a way, but we must introduce a very, very restrictive hypothesis of production sets. More precisely, there is at least one firm which has the free disposal technology, which is able to destroy singularly every good by starting from any process which belongs to its production set. So, suppose that there is a firm which has free disposal technology. This means, let's separate. This means that, you remember, given any production process, every point which has all the components less or equal to those of this particular process is another element of a production set. And as usual can destroy every good singularly by starting from YF. This is a general form of free disposal. Free disposal technology. Well, if there is at least one firm which has this technology, then in equilibrium all prices must be greater or equal to zero. It is impossible that in equilibrium there is a negative price. Why? Suppose assurdo that there exists a good I such that the corresponding price, equilibrium price, is negative. Let's suppose that the optimal process is Y star F. Clearly it is a process which maximizes profit of F firm. Now consider the process YF, which has all components equal to those of Y star F, but for the height, which is diminished by 1 unit. Sorry. F1, Fi, Fn. This is the process YF, process Y star F. YF is here. For example, if a good I is the first good, is an alternative production process with all the components equal to those of Y star F and the highest component which is equal to the corresponding component of Y star F minus 1. This vector is another possible production process for the F firm. Because by free disposal technology, here a unit of good I is destroyed without employing any other factor of production. At this point, let us compute the profit of this alternative process. By definition, is P star times YF equal to P star times Y star F, and then here minus 1 multiplies P, and therefore we have minus Pi. But since Pi is a negative number, this term is a positive 1, and therefore this is greater than P star times Y star F. Is it clear? But this is impossible, since according to this price system, Y star F maximizes the profit of the F firm. And here there is an alternative process in YF, large YF, which guarantees a greater profit. This is impossible. And this absurdity follows from the assumption that the price of one good is in equilibrium a negative one. So the result is the following. If at least one third verifies free disposal, then P star must belong to the non-negative orthant of the n-dimensional Euclidean space. It has all positive components, but not all null components, because we excluded this case by supposing that at least one consumer is never associated. We obtain this interesting result. But note that free disposal is a very restrictive assumption, while the assumption that there is a subject which is never associated is reasonable. This alternative assumption about technology is not reasonable. It's not verifying reality. Because in order to destroy some good is always necessary to employ other goods as a factor of destruction, so to speak. Or we obtain this result. Well, let us have a short break.